Dobrý den, vítám všechny na našem Prague.js meetupu a chtěl bych za náš Prague.js tady přivítat naše přednášející, kteří dnes je tady Yehuda Katz, který bude mít první přednášku, a tady Tom Dale, který bude přednášet o Ember.js. Tak je všichni přivítejme v Praze. A now, please continue with talk, Yehuda.
All right, awesome. Hey, so I'm going to be talking today about how the next version of JavaScript makes your life better as a JavaScript programmer. So I assume everyone here is raise your hand if you write JavaScript on a regular basis. I feel like more people should be raising their hand at a JavaScript meetup. So this talk is basically about how how ES6 is making it better. For those who don't know, ES stands for ECMAScript. So JavaScript is actually a trademark owned by Oracle. So I think people have tended to move away from calling it JavaScript in official contexts. Presumably they do not want to get sued. I think Netscape still has a license, though, to use the word JavaScript. Well, I guess Mozilla. So basically what I'm talking about today is JavaScript. So Brendan Eich gives a bunch of talks along these lines. Definitely go watch him. He's much funnier than I am, and he has a lot more experience, the most experience with JavaScript since he wrote it. So his context is much better than mine. But what I wanted to talk about today was focus a lot more on code that we all write today on a regular basis as JavaScript programmers, and specific targeted ways that the next version of JavaScript is hoping to address those issues. So less about context, less about grand visions for the future, and more about specific issues that everybody who hears about ES6 thinks aren't being fixed and how they're actually being fixed by the next version of JavaScript. So first of all, why should you care? There's actually a lot of reasons to care. So when I said I was giving this talk, a bunch of people told me, I don't think this matters to my daily life. This sucks. You should stop talking about this. Maybe in like 5 years when it is in all browsers, we could talk about it. And I want to tell you there's actually a lot of reasons to care. And one or more of these reasons will probably apply to you as a JavaScript practitioner. So the most obvious one is just Chrome or Firefox plugins. So as soon as a feature rolls into Chrome, you can now use it if you're making a Chrome extension or a Firefox extension. Firefox already implements about half of ES6 right now, and Chrome implements maybe like a third of it. So Chrome and Firefox and Safari and some future version of IE will implement a lot of these features. So that's number one. And the same is true about Node. So if you write any Node, that includes like little Node scripts. If you use Grunt, if you use Node for any reason really, you will basically get to use these features as soon as they exist in Chrome. And what's really great about this is I think people are so used to the limitations of ES3 because they have to target IE that they just have lost track of even the improvements that are in the last version, the version that have been in browsers for a long time, the version that's even in IE9. For example, Tom today, I was showing him getter and setter syntax that is in all browsers as early as IE9, and his mind was blown that this syntax existed. I think a lot of people are not aware of syntax. So getting aware of what features are there in new browsers, it might really make a difference if you're trying to do something to get either nicer syntax, nicer semantics, features that didn't exist before, etc. The third one here is evergreen browsers. And what I mean by an evergreen browser, I think Alex Russell coined this term, is browsers that automatically update. And what I mean by this bullet is more and more browsers are becoming evergreen browsers. Even IE10 is an evergreen browser. IE9 is an evergreen browser, browsers that automatically update, which means that over time, instead of new features come out and slowly, you have to wait for old browsers to go off the map. You know, Firefox 3.6 has been around for a lot longer than Firefox 4 was around, because as of Firefox 4, things started auto-updating, right? So you should get out of the rhythm of not caring about what's coming next, because very soon, even now, you can start using features more quickly after they get released than you were able to before. So if you're a practitioner and you don't want to be old and rusty, keep an eye on what's coming out because it's going to start mattering. And then finally, for older browsers, a lot of the features I'm going to talk about today are transpilable, and by that we mean just convertible into ES3 syntax, but with ES6 semantics. There's two projects that are doing this. Traceur is a more complete version by Google. It transpiles a lot of ES6 syntax into ES3 or 5. And TypeScript, which is by Microsoft, people know about it because they announced that it adds some type verification at compile time to JavaScript, but it also backports a lot of syntax to JavaScript. So transpilers will help make it matter. So basically what I'm saying to you is, I think you're being a lazy JavaScript programmer if you decide you don't care about ES6. I know it's comfortable. It's the way we've all programmed. It's very defensive. But I think it makes you a bad programmer if you take that tack. No offense. OK, now one of the most important constraints about ES6, which I need to talk about up front, and I think the definition of this is a little bit murky, but I'll try to explain it as best as I can. This is a rule that was adopted by the committee. So I'm on TC39, which is the committee that works on this stuff. And pretty much everyone agrees to this, although the exact contours of it can change from time to time. But the most important contour of this is there are no modes. So the first bullet, no script type equals application ES6, no use ES6, no pragmas. The use strict pragma, which was in ES5, was basically a one-shot deal. There were some things that were extremely egregious about old versions of ES3, which came out in the late 90s. So fixing those was deemed extremely urgent and worth a mode. But that was a one-shot deal. We're not doing that again, which means up for discussion are not things like make var mean a different thing. Stop putting things on the global scope. All these things are simply not up for discussion because they would break the web. They would break existing features. If there's existing syntax, if function does something, we cannot change function. We cannot change object literals. We cannot change what arrays do. Obviously, new syntax can come with new semantics. That's what new syntax is for. If it only had the exact same semantics as the old syntax, it would not really be worth doing. But existing syntax cannot have new semantics. And then I just want to call out, there's a couple of exceptions, things that you might consider exceptions, but which are not really exceptions. So modules, which I'm going to talk about later, automatically opt you into ES5 strict mode. And again, strict mode in ES5 was mostly about fixing bugs in the language. So really, you want to be opted into strict mode. So modules opt you into ES5 strict mode. But again, that's new syntax. You have to type the word module, which would raise an exception, a parse time exception in ES5. So this is only a little bit of an exception. And inside of generators, the word yield is a keyword. So you cannot have a variable named yield inside of a generator. But again, a generator is a new feature with new syntax, which you have to opt into. So if you make a new function, which is a generator with new syntax, and say yield equals something inside of there, I get that it's kind of an exception to 1JS, but it's basically, I don't really have a lot of sympathy, mainly because we don't have a lot of choices. We have a few options, and that's a very targeted one. So I basically want to talk about, I'm going to talk about things that are considered broken in JavaScript. I think this is probably the main one. So Brendan's talk was posted on Hacker News, and somebody said something like, you guys need to stop worrying about gizmos and start worrying about fixing the really important things like global variable scope. So the first thing I want to tell you is global variable scope is already fixed in the last edition of JavaScript. But let's talk about what people mean by this. So here's a particularly nasty piece of code. By the way, almost every slide for the rest of this talk is code, so hope that's OK. So here's a loop. Raise your hand if you know what's broken about this. You don't need to. So a few people. So most people don't know what's broken about this. It looks totally fine. What's broken about this, and what will happen if you try to run this code through JSInt or JSLint, don't make functions within a loop. How many people now know what the problem is, what the actual bug is? Still, very, very few of you. So the problem is that var person is not actually scoped to the loop. It's actually scoped to the entire function context. So that person variable gets every iteration through the loop gets changed, and the closure, that alert person, is going to be modified. And so basically, every single one of those callbacks is going to be closed over the last value of person. Obviously, totally wrong, totally not what you expected, but a consequence of the way variable scoping works in JavaScript. Now, ES6 has a new feature called let, and a lot of people say, what's wrong with var? Let is stupid. Why are you introducing a new keyword? And basically what let gives us is it gives us the scoping that we would expect. So if I said raise your hand if you know what the bug is here, hopefully no one will raise your hand because there is no bug. This actually works. This actually works as you would expect. So those let variables actually get scoped to the specific invocation through the loop, right? So instead of person getting changed over and over again, the scope of that person variable is only as long as the iteration through the loop. And this is actually very good. This fixes a lot of bugs. I think I use this example because it's the most egregious example of block scope where it does something totally unexpected. But basically, at any point where you put a variable inside of curlies in JavaScript and you imagine for some reason that it only lasts for the duration of that block, which is I think what most people expect until you become a very advanced JavaScript programmer. By the way, this thing bites me basically every time I do it. JS hint always reminds me that I'm doing something wrong. So basically, this solves, I would say, one of the most serious problems. So then this is what I mentioned before, leaky globals. Hopefully everybody knows. Raise your hand if you know what's wrong about this. Hopefully many people. So the problem here is that you are trying to assign x equals 1, and in ES3, in the version of JavaScript that shipped in 1998, this basically meant put a new variable called x in the global scope, which means on window, and assign it to 1. And if you try to do this with JS hint, it will tell you, hey, what are you doing? You're trying to assign a variable that is not defined, because if you want to put something on window, you should say window.x, you should be explicit. Probably this was an error. But awesomely, in ES5, which is in all browsers as of IE9 even, and as you can see, this usedirect thing doesn't mean anything in older browsers, right? So it's simply an opt-in for browsers that know about it. This becomes a compile time or runtime error. It becomes a runtime error. It says x is not defined, but you don't have to have a special tool. The browser will tell you, no, you are doing something wrong. You are making a mistake. So basically, as of ES5, if you use strict, which you should, if you try to make the mistake that I think everyone thinks is the biggest mistake of ECMAScript 3, you cannot do it anymore. This mistake does not exist. Sorry, it does not exist anymore. Now, what I said before, this is actually really cool, is in ES6, if you use a module, and I think obviously modules are going to not be immediately used because they're not going to be supported by all browsers, but let's fast forward a few years to where people are tending to use features that are in ES6. If you use a module, it implicitly opts you into use strict. So basically, if you put your code into a module, you're going to get the proper behavior. Essentially, in ES6, if you do what you're supposed to do, you cannot accidentally leak global variables in the way that everyone thinks is the biggest mistake that JavaScript ever made. So fixed, done. Okay. So here's another one. Here is an example of some classes. I have var point2d equals and its function xy. I have a prototype, and then I try to subclass it. Raise your hand if you can see one or more errors in this code. Yeah, so this is the thing that sucks about about JavaScript prototypal inheritance, is that I'm sure this looks like the incantation to a lot of you who have copied and pasted the incantation before, but it's actually incredibly broken. There are many bugs. So let me go through some of the bugs in this incantation. So first of all, I need to, via yet another incantation, call super, right? So if I don't call super, there's going to be a bug there. I have to basically invoke the parent. But actually, I still have a bug here because I need to actually call super with the arguments. So this original fix forgot to pass in the arguments, but obviously the parent wants xy. So I got to do this thing, which now we have gotten to a thing that maybe 0.1% of JavaScript programmers even know what it does. Probably more than that in this room. But very, very few JavaScript programmers even know what apply does. And in order to do a simple thing like subclassing a point, you have to now get into the intricacies of craziness. So this is for people who say, what's wrong with prototypal inheritance? It's great. JavaScript doesn't need objects. We have prototypes. You can just use those. So it's true you can use those, but the incantations are bizarre. The incantations require you to basically get down into the muck of how JavaScript's implementation works in order to do relatively simple, straightforward things. There's still a bug here, though, which is, see what I did there? So you can't just copy the prototype, because then if you modify the prototype of the child, then it will modify the prototype of the parent. So now you're modifying point2d instead of point, so that's no good. So you got to use new point2d to make a new instance. At this point, I think most people know that this is the incantation, but basically have lost the plot on how any of this actually works. And actually, this is still broken, because if the constructor in point2d had a side effect like alerting or console.log or something like that, and modify the DOM. I know you're not supposed to do that, but people do. So if the constructor had any side effects, you would be invoking it randomly when you run the script. Probably not what you want, so you need something like this. Object.create point2d.prototype to get that to work. requires object.create, so if you're still trying to target older browsers, you need to polyfill that. So basically the point that I'm trying to make is, yes, there are prototypes. Yes, you can do it. Yes, you can do the incantation, but basically, it's a disaster. Nobody can do it correctly. Everybody makes mistakes. Everybody fails. It's basically a copy and paste job. This is not what we want from JavaScript. This is basically what we want from JavaScript, and this is what is in ES6. Okay, so the reason I did that whole build-up was because if I just showed this slide, probably half the room would say, why do you introduce new syntax? We already have a perfectly serviceable option. No, it is not serviceable at all. It's a disaster. I write it all the time. It's terrible. Okay, so the cool thing about this is that it doesn't do anything different from what I showed before. It does exactly the same thing that I showed before, has exactly the same semantics, but says what you mean. So let's go through what a few of the things that are going on here is. First of all, we have a new keyword called class. It basically makes a function like it did before, but it is representing the thing that you mean. That's number one. Number two is there is a method inside of the class called constructor. And that constructor is basically the constructor. It's basically the function that point2d will point to. Yes, I know, it's amazing. So if you don't provide a constructor, it will have an empty one automatically for you. But if you provide one, it basically point2d will be that function. Okay, concise method. This is an awesome feature in ES6. You don't have to type equals, colon, function, parentheses, other. You can basically type the thing that I think many of us have typed by accident many times. Concise methods basically instead of the longer version. And subclassing. Subclassing is easy. You don't have to know about object.create and prototype extensions and make sure not to make all these kinds of mistakes. Notice that there's no constructor in the subclass. If you leave out a constructor, it automatically delegates to the parent. Awesome. And I just threw in here for fun the fact that I don't have to concatenate strings with plus anymore. There is a new feature called string templates, which basically allows you to do string interpolation in JavaScript using $curly. Basically does what you mean. I don't talk about this in any slides, but this also allows you can do string templates with specific semantics. So you could have HTML or escape, raw, etc. Before the backtick, and that will basically let you take the interpolation and do special stuff with it. So similar to in Ruby, there's like %w and things like that to get special semantics out of a string interpolation, and so you would have like w backtick and then whatever you wanted. And those are, unlike in Ruby and JavaScript, in ES6, those are user-defined. So you can describe the semantics however you want. So the point is that our goal here is to eliminate error-prone incantations. Yes, we have not introduced any new features. Everything that I just told you is semantically identical to ES3. The problem is that when you do it in the ES3 or ES5 way, you make mistakes. Everybody makes mistakes. I make mistakes. And we want to eliminate incantations that you have to copy and paste and that people constantly make errors in. Here's another example of that. So here is some code from Ember. You can see that I'm extracting off the slice function, ember.mixin, and the first thing that I'm doing is extracting off. So many of you might not know what that is doing because it's another incantation, but I'm basically getting an array from all the arguments after the first one, and then I am passing in arguments to apply mixin. So basically, if you've written a lot of JavaScript at a library or framework level, you've written code like this, it's basically to deal with optional or variable arguments. And another thing that really sucks about this is that if arguments was an instance of array, I could just do arguments.slice. But because arguments is not an instance of array in JavaScript, I'm forced to extract off the slice method and then call it using arguments as this parameter. It's basically ugly. It's basically something you can easily screw up. It's something that has performance implications. So ES6 basically makes this easy by letting you say what you mean, which is a REST argument. So in Ruby, this would be star args. In JavaScript, it's ... args, which is it's similar to what it looks like in other languages, in C, etc. And basically, I can eliminate all those incantations of extracting off all the arguments after the first one by simply putting ... args. And that is a real, honest-to-goodness array that I can just pass in. So I can basically delete an entire line and replace it with something that is obvious what it is doing. Here's another variant of the same incantation. I have ember.run.schedule, and I'm basically passing the arguments directly into another method. And something that you'll notice here is that loop.schedule is actually passing in loop to apply. So it's basically like calling loop.schedule parentheses and then the arguments, but there's no way to pass in the same list of arguments along, right? So I can't actually express the idea of, I just want to pass along the arguments that I got without doing this weird apply shenanigans. In ES6, you can basically say what you mean, right? Get my arguments and then send them along as a list of arguments to ember.run.schedule. So again, say what you mean. don't say what you didn't mean. So here we have rest arguments again. This basically just means the same as it means in other languages. Give me an array of all the arguments that are left at this point. And this is called the spread operator, which means take this array and send it as a list of arguments to the function. I don't have slides for this, but the spread operator can be used after, the spread operator and rest operator could be used after other arguments, right? So you could say loop.schedule, foo, comma, ... args. Okay, here is some code from jQuery. I simplified it for easy consumption, although I don't know if I would consider it easy consumption. So core slice is basically the same thing. jQuery pulls off the slice method and then makes it available to its internals as core slice. So we have slice. It's basically, this is actually, I extracted it off into several variables to make it easier to put on a slide, but jQuery actually does this.pushStack, core slice.call arguments.join, comma, core slice.apply this arguments. And that is even harder to read than this, so I extracted it. So basically, this is like, what is this doing? You have like many, many characters, and it's completely unclear what is going on here. So here is a similar thing in ES6, right? So you have the slice operator, you do ... args, and then you pass along the, you do core slice.apply this arg. So there's still a little weirdness here because jQuery object is not a real array, so we have to use arrays slice method in order to copy it, which is still not great. But we can do args.join comma, we can do ... args, which is a lot clearer. So basically, what's happening here, by the way, is that jQuery, when it does pushStack, actually keeps a string explaining what exactly was the reason for calling some operators. So you can basically look at that string and understand, oh, you called slice, basically. That's what happened here. Okay. So rest arguments again, and importantly, this args is a real array. So we don't have to call core slice.join or anything crazy like that. We can just do this directly. And actually, what was I meaning by this? And in ES6, there's also classes, like I showed before. So you can just go class jQuery, and then you can use concise methods, which you could have used before. But basically, this is even clearer. This is even clearer about what it is that you're trying to do. Maybe in ES7, so we've talked about this a little bit more, maybe in ES7, we will make it possible to subclass the core primitives. So jQuery could itself be a subclass of array, and then it could just call super with ... args to get it to do the normal array behavior. Because basically, if you look at what's happening over here, that's essentially what's happening, right? It's extracted slice off of normal array, and then it's applying this as a parameter to slice. Really what we want is to just be able to subclass array and call super. It turns out that subclassing array is a ball of crazy, and so we probably have to wait till the next version of JavaScript so we actually ship ES6. But I think there's a desire to be allowed to subclass array, and then we can make it even clearer. And this, I think this is rather clear about what's going on, right? We can see that we are just simply subclassing slice. We want a super with the same arguments that we passed in, and we can join the arguments with a comma. And that's significantly clearer than the first slide, which just looked like, essentially like garbage. Didn't look like anything. So super is there. Here's another one. Here's some Ember code, and you can see we have a render buffer. We pass in tag name, and the very first thing we do in that function is say, take the tag name, and if there is no tag name, give me the tag name that came from my class. And the cool thing about ES6 is that you can use parameter defaults for this case. So this is a common case that happens all the time. You basically say, if nobody passed in something, I want to use this. And so you can just say tag name equals this.tag name, and then you can skip all that code. I'm using this.tag name instead of this.get tag name because other features of ES6 will also make it possible for Ember to eliminate the get and set. So I don't talk about that at all, but that is for me, a nice feature of ES6 is that I can finally do that. So parameter defaults. And you can also do the same thing inside of a class. So I could theoretically go class view extends ember.object, and then inside of there I could use parameter defaults. So one thing that you should be noticing is that there are some features that are available, there are new features that are available, and they basically work the same way inside of classes, which are just syntactic sugar for prototypes and objects, and they work the same way inside of classes. So the goal here, again, is to say what you mean. If we want to say, I want this thing to be a default for this parameter, we should be able to say, I want this thing to be a default for this parameter. And parameter defaults actually are really awesome. They basically are expressions that get run as though they were inside the function. So you can basically put whatever you want in there, and they'll get run and bound before you run the function, but as though they were the first line of the function, which is great. So you can't see this. I think I meant for you to see it. Basically what's going on here is that if you look at a DOM node that jQuery touched, you will see that there's a property called jQuery 1820 something something long thing. And basically what jQuery is doing here is it's generating a unique name to avoid collisions. If this is Ember. Ember does ember.meta. On an object, we do a similar thing. We create a unique key, and we stick it in there. And that's basically just so that we can have a place to stick things, and we can have a place to stick things, and we can be guaranteed that it won't collide with somebody else. Right? We want to make sure that we have generated a truly unique key. So ES6 adds a new feature that basically targets this use case called private names. Here is the raw primitive way of doing it. So you can basically say, give me a new symbol. So you probably know that you can only put strings inside of the brackets. So ES6 basically lets you put one new thing in, which is a symbol. And a symbol is basically just a property name that is guaranteed to be unique. The VM will guarantee that it's always unique. So you can make one, you can close over it. And then inside of jQuery.gwid, we basically say, OK, let me use the jQuery sim to go get some stuff. And basically what this means is it has exactly the same semantics as generating a big string, but it's a lot clearer. And there's actually, if you pass into the symbol a string, that will basically be useful for debugging. So you can say like jQuery symbol name. And then perhaps a debugger like the Chrome debugger would say like, this is a private name, but this is what the person making the symbol said it was for, instead of it being jQuery some huge number. And so this is the bracket syntax. And there's also a new dot syntax. So you can say l dot at jQuery sim instead of the brackets, which reads a little bit nicer. And there's also a, instead of this let jQuery sim equals new symbol, there's also a syntax for making symbols. This basically works exactly the same way. It's just a syntax trigger for creating a new symbol, just because we anticipate that it will be fairly common. And I'll show you why in a second. So here is a class. So in this class, I'm creating a new underscore property. How many people do some kind of programming where they use underscore properties for privacy? So a few people. This becomes a lot more common when you do more complex stuff, when you do subclassing. You end up using underscore properties because you want to make sure that the people below you, they'll use regular properties and you'll use underscore properties. So here I make a new class. I create a constructor which saves off the ID as underscore ID, and then I use that inside of get. So get element, by the way, is the thing that Tom was mind blown existed. That already exists in object literals in ES5. So if you only need to support IE9, you can use getters today. Really cool. So there's a problem though. So imagine, okay, now I subclass button, and the whole point of underscore ID is that it's not part of the public API. So the guy on top did not tell anybody that underscore ID existed. So now I'm like, awesome, I'm going to go subclass ember_view, great. So I do set UUID, and I set this underscore ID because, again, I am trying to make it private. So I'm using it personally as a private variable. Awesome, great. Now the problem is that when I go to call, when the parent goes to $.get.this underscore ID, I'm going to get the one from the UUID. So now these two namespaces, even though they are meant to be isolated from each other, end up clashing. So you end up being forced into exposing your internal implementation or using more crazy names, like SproutCore used to do underscore SCAC for SproutCore array controller underscore and then the name, which is basically encoding the name of the class that you're inside of the underscore name. And it just becomes really ugly. It becomes really hard to understand what's going on. So it's another say what you mean, right? So there's a problem that as we try to get more and more safe in terms of isolation, it becomes harder and harder to understand what the programmer is actually saying. There gets to be a lot of noise. So ES6 uses this new private name to give you this kind of privacy. So if you declare a private name inside of a class, that basically makes a private name that is visible for the entire class and not outside of it. So I can make private ID, awesome. I use this .@ID everywhere. That's a unique name that only exists for the purpose for the inside of those curlies. And then this class button extends view. It says private .ID. That's a completely different ID. It's only lexically visible inside of that button, and so this code will work fine. This is sort of giving you the benefits of like a private method or private field in Java without a static compiler. And I think it's a pretty clever solution to the problem, right? So it basically uses the fact that we have lexical scopes to give us this feature. So again, it's used inside of a lexical scope, and this @ID is inside of a different lexical scope, therefore it's a different @ID. And let's say I say, okay, awesome, I have @ID for privacy, but I want other people to be able to use it. I want other people to be able to use my ID for some reason. Let's say it's a plugin API. I don't want it to be part of my public API, but I want other people to be able to, for reflection purposes, see it. You can basically just export that name, right? So that's just it's an object that the VM knows is a unique name. I can just make that available, and then people below me can actually use, other people outside of me can go grab that private name and use it. So basically the point that I'm making here is there is a way to get this done today, but it basically is a leaky abstraction. You end up using underscores, and basically if you want, the shorter you are, the more likely you are to collide, and the longer you are, the more likely it is to become unreadable and just a mess. So say no to leaky abstractions. We want to add syntax that makes it easier to say what you mean and not leak the abstraction that you're trying to build. So iterating. I actually did that backwards. So here we have var array equals 1, 2, 3, and then we loop through it with a for in loop. How many people know what the problem is here? Yeah. I'm actually happy that a lot of people don't know what these problems are. So this is actually really bad. Don't ever do this. Don't loop over an array with a for in loop. The problem is that a for in loop loops over the properties. And this happens to work because a lot of times the only properties of an array are the indexes. But it's perfectly legal to add string names. People can override array.prototype with non-enumerable properties. Basically, this is totally wrong. You should not do this. And that sucks. And ES6 adds awesome new objects. It adds a map. And the purpose of a map is that you can have keys that are not strings. So an object in JavaScript today is a map, but it can only have keys that are strings. A map in ES6 is an object that can have keys that are not strings without introducing new leaky abstractions like in existing solutions. But if you do this for in loop, which is the normal enumeration, this doesn't work at all. This is going to give you the list of properties that are enumerable on the map object, which is completely not what you want. So you basically lose the ability to do enumeration. And basically, this is a consequence of 1JS, right? 1JS means we already have a semantic for what enumeration means. People use it today to copy objects. We can't simply change what that means. So we're basically stuck. We can't make maps have good enumeration syntax. And that sucks. But we actually can fix it by introducing new syntax. So here we have an array, and we can go for let item of array, and now this will do the right thing. So if you're thinking, it seems like you're just hard coding new syntax with new broken semantics, hold on, I will get to that in a minute. And of course, for maps, we can do the same thing. We can make let key of map do the right thing, and here we're going to get console.log key map.get key. And actually, if you did let bracket key value of map, you would get the key and the value. So you can say array key value. That will work. And that's actually because of a feature that I don't talk about at all here, which is destructuring assignment, which is everywhere in JavaScript. If you use CoffeeScript, you might know about it. I don't talk about it because I don't think I'm talking today about things that really bother people writing JavaScript code today. And I think destructuring assignment, while a very nice feature that I will be happy to have, isn't really targeting massive pain points that people have in JavaScript today. But it existing in the engine lets you do things like let bracket key value close bracket of map. Now here's the really cool thing. The really cool thing is that this is not just a feature that allows JavaScript to provide enumeration. You can provide whatever enumeration you want on top of your own object. So here I have a node object. This is a linked list, right? So it has a constructor which takes an item, and it basically sets the item. And then basically you're going to go and say that item.next is some other item. Lets you make a linked list, and you want to iterate. So basically the way this works is that we are importing a private name called iterator from a namespace called iter. I'm going to talk a little bit more about modules in a bit, but there's basically now a syntax for importing private names, importing names, period. And we're basically making a new generator there with star at iterator. Looks a little bit weird, but it basically does, it creates an iterator. And inside of there, you can see there's a yield. And basically what yield means is, here is the value that I want to return for the next time that someone tries to go through this loop, right? So you say, here's the node. While there is a node and its item is not null, then yield the next item. And so this is a generator at star at iterator, and that is yield. Yield basically says, here's the next item through the loop. And so here's an example of using that. We can say, list is a new node, the next list is a new node, the next list is a new node, and then you can just loop over it using for of. And the list doesn't exist at all. The browser doesn't know anything about this list. We created it ourselves, and we also said what for of means. So if you're implementing your own domain objects in the browser, you can also say what it means to enumerate over them. So this is pretty cool. And here is the primitive. This is basically what is happening inside of a for of loop. And people in TC39 don't think that people will do this a lot. But this is basically what the API is under the hood. And so it basically keeps calling next, 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 and then it catches stop iteration. And basically the reason for this API, if you're familiar with the Java API, is just has next, which is the other way to do this, to keep checking has next, is actually a pretty complicated API that a lot of people get wrong because of the fact that they are required to keep in sync has next, and make sure that has next always returns the right value. And it's just a source of common errors. So basically the alternative is that there's an exception that gets thrown. There needs to be some out of band value, and that's an exception. This would really suck if you have to do it a lot, but the idea is that you will usually use a for of loop. And in fact, the exception will never get thrown because the browser will know better. The browser will know you're in a for of loop, and it will know to not have the generator raise an exception in practice. But this is what's happening. If you wanted to iterate yourself over a loop, over a thing that was iterable, you could do this. So stop iteration is the name of the exception, and there's an isStop iteration function that you can use to check. So you don't have to do like an instance of check or something. Okay, so that's iterators. I think that's really awesome. And again, I think that the current enumeration semantics are sufficiently broken that I think this is actually a pretty big win. It basically means that when you make your own objects, you can enrich them with the power that the original writers of ECMAScript had to give their own objects with enumeration. Okay, so this is callback hell. This is a pretty common thing that you start to see when you have to do things in a row. You end up with nested loops. Nested callbacks. Now, you could flatten this by using promises, or you can flatten this by calling functions that are in the flat scope, but basically it just gets ugly. No matter what you're doing, it gets ugly when you have to have nested callbacks. And this yield syntax, because of the fact that it's not just an iterator thing, it's flexible enough with that next API. Basically, there's already a library called Task.js by Dave Herman that allows you to write something like this. And this actually, with Task.js, which works in Firefox today, and jQuery, this will work today. You can do this today. Obviously, that is a limiting set. You have to have Firefox, but the idea is that ES6 will be in more browsers. So it's basically spawn is basically saying, okay, take this generator and just keep calling next. And if the thing that you call next on is a promise, so if Ajax A is a promise object, then just run something else in the meantime. Run some other spawn function, or return control to the browser. And just resume whenever you have some data to resume. So it basically lets you take these crazy nested callbacks. I think if you look at this, you'll see this is significantly nicer than callback hell, and it basically encodes the same semantics. The only thing is that you need a generator, and you need yield, and yield basically just waits for a promise to resolve. So if you're familiar at all with jQuery deferreds, they implement the same promise API, and the idea is that people will implement, Ember implements promises in some of its objects, and the idea is that more and more people will implement promises A, which is promises spec, and then this will just naturally work. You'll be able to say animate and then yield to that. You'll be able to say, give me an Ember object, give me post.find1, yield to that, etc. Internally, the way this works, I showed generator.next, which basically just continues. There's also generator.sendValue, which is basically, here's what the value of the yield should be inside of the generator. So you can basically assign the yield to something, and you can send the answer in. And you can also do generator.throw. And basically, generator.throw means that you get an exception inside the generator. So that means that you can just do try-catch around something. You say try, yield something, and then you can catch, and you get an exception, proper exception. So you basically avoid the insanity that is Node's API, where the first parameter is an error. You have to do crazy stuff to pass it along. Basically, you get regular-looking JavaScript, quote-unquote, synchronous API using generators. Okay, so before I leave the topic of this, I want to say, for me, this is the number one feature improvement of ES6. I think the ability to finally get out of callback hell is a huge deal. And for me, I'm waiting to see if the Node community adopts this with gusto as soon as it lands in Chrome, in V8, just because I think this is probably an order of magnitude improvement in Node-like code. So in jQuery, I think there's fewer nested callbacks. You tend to be waiting for a top-level event a lot. But in Node, there's so much callback soup. And I'm waiting to see if they adopt this with gusto. I would love to see Node rewrite their core primitives in terms of promises so that they could use a library like this and let you write synchronous-looking code with all, from the Node perspective, with all the performance benefits that normal asynchronous code has. I think that would be amazing. That would be great. So generator, wait for promise to resolve. Okay. The next topic is modules. So modules is a new feature. I think most people see modules and they say, that seems boring. I don't know why you need modules. The script tag is great. When people say that, it feels like when Alex Russell said, we don't need no stinking compilers, refresh is the browser's compile step. And I'm like, so Alex is great, he writes JavaScript code for real, but I don't, he wrote Dojo, which has a compiler, so I don't really know what he was talking about. Anyway, so there's a bunch of module implementations for JavaScript. So it is not the case that this module thing was invented out of whole cloth by the committee. This is a real problem that people are struggling with. So AMD modules is one way that people have tried to solve it. There's a spec called CommonJS, which is implemented by Node and other browser libraries. There's this thing called YUI.add, which is another module system. I wrote a thing called Minispade, which is a really, really small module loader. There is the just wrap everything in an IFI, which is this pattern, right? So there's a ton of patterns that people use for modules. The thing that sucks about them is that they're incompatible. So if you use YUI.add and you want to use AMD modules together, they don't know about each other. And they are trying to operate inside of some kind of asynchronous system. The browser doesn't really know what's going on. Every time you obscure things from the browser, you make it harder for the browser to do optimizations. You can't do any kind of semantic checking, so you don't really know where things are coming from. Like, it's encoded in the semantics of the module system, but the syntax doesn't really expose it. And basic ES6 modules are a way to use the power of new syntax to give us essentially the features of all these systems in an interoperable way. So the idea is that you will create a module, and again, remember, modules implicitly use strict. And then inside of a module, you could import things from other modules. So you could say import object from core. We're assuming I'm inside of a namespace here that understands. So this is like Ember, right? So we're assuming that we're inside of a namespace where core is defined as something, and object is inside of that. And then I can go make view as object.extend, container view as view.extend. Obviously, this is a rather simplistic example, but now we can have a views module, which would be like Ember views package, and it would export view, container view, and collection view. And so now I can encapsulate in the same way that you would inside of an IFI and what Ember does inside of its individual files. You can encapsulate variables. So here we have a few that we exported, but you can have other ones, and they just simply will not get exported. You can have private names inside of here that will simply just not be exported. Now this syntax also supports loading from other files. So you can say import jQuery from jQuery.js, or you can provide a URL, and that basically will load it as a module and then make the variables inside of it that you tried to import available through the namespace. I think that's my last slide, so I'll just talk through it and then open it for any questions. So you can import through a namespace. And again, there's the destructuring assignment, which I talked about before, which also lets you import multiple things. So one of the things that really sucks about the CommonJS pattern, which tries to do the same thing, is that you have to go like, let's say you're trying to load like a parse.js, or what's it called, reflect.js. You go var reflect equals require reflect, and then inside, then you have to go like import individual things, right? You have to import individual variables that you want from inside of that reflect module. And so what people ended up doing in AMD and in CommonJS is they ended up always exporting a single object, and that object is just the thing that you use. But actually, so Ember does this thing a lot inside of our own code, where we go like var get equals ember.get, var set equals ember.set, so we don't have to say ember.get and ember.set everywhere. And it would not be good if you had to import an entire module, because that's the exact thing we're trying to avoid. So in the module syntax, you can go let open curly, get comma set, close curly from Ember. And that will only import those two variables. And one really awesome thing about the ES6 module syntax in general, is that because of the fact that because we are turning on strict mode, so we do not have access to the global scope in here, the compiler, the JavaScript compiler, when it looks at a file, can see all the places where all the variables are coming from, and it could check to make sure that you're not using you didn't typo a variable, right? It knows exactly where all the variables are coming from, and and actually, because import is a syntax, it looks synchronous, but it can actually parse the file, find all the imports, load the imports asynchronously, and then continue on loading this file once those imports are done. So this is something that if you're trying to polyfill on top of existing JavaScript semantics, you have a hard time. You have to do a lot of weird stuff with closures and functions and arrays of strings. But if you have new syntax, you can do something that looks really nice. It looks synchronous. It looks like you're doing a sensible thing. But behind the scenes, the browser can do a lot of smart stuff. You can do, like I said, you can do free variable checking. You can do automatic async loading, etc. So I think that's pretty awesome. So that's all the features of ES6 that I want to talk about today, and I will take any questions anybody has. Actually, while the microphone is going back, let me just say one more thing, which is I think a lot of people, because ES6 is the first version of JavaScript since ES3 that has significant new features in it, I think a lot of people have gotten very comfortable with JavaScript, and so when they see all these new features, they say, oh my God, what are you doing to my JavaScript? And they freak out and just revert into the fetal position and assume it's crazy. To the extent that you trust and believe me, I will assert that I think the list of things that we have added to ECMAScript 6 is actually a fairly constrained list of things that are trying to tackle wide problems that are problems that a lot of people have that are common. And so things like generators, you might look at it at first and say, oh my God, you added a star to function. I think that's a lot of people's complaint. Why are you using function star? And they don't stop to think about how to make it backwards compatible, how to make the syntax good. But you shouldn't think about the fact that sometimes when you write your own custom iterator, you have to use function star. You should think about the fact that you are able to properly iterate over your own objects, which is not possible today in ES5. So you should not think about the fact that there is a new class syntax. You should think about all the insane shenanigans you had to do before to get similar semantics. You shouldn't think about, oh my God, module is a thing. Why did they have to add a module feature? AMD is good enough. You should think about the improvements that we are able to get by having a syntax, concise syntax for modules that you were not able to do before using the hacks, essentially, that we did before. So I will take any questions anybody has.
So first question. Thank you, Yehuda. It was an excellent talk.
Thank you.
I completely agree that the generators are like the most exciting feature in ES6, and they like uncover a completely new set of design patterns that you include.
Absolutely.
And as a long-time Node.js developer, I found the pot shot at rewriting into promises quite interesting. Why do you keep repeating that you get code that looks synchronous but fundamentally is asynchronous? Why do you think that's such a good idea, actually? Because it actually fundamentally hides the execution order from you and makes you not realize certain things that you probably should realize.
Cool. So I'm going to quote somebody that I forget who it is, but someone will probably correct me. Every time someone talks about this, they say, it lets you write synchronous code. You know the code you can read. And I think I fundamentally agree with that. I don't think the type of code, when I look at node code, I don't understand what's going on. And I actually think that the way that ES6 did it is actually a good compromise. So ES6 does not, so if you use a threaded language and you call a function, anybody downstream can pause you. So you could say like foo, and for all you know, the next line of code is run an hour from now. I think for JavaScript, for code that is running in a fundamentally asynchronous environment, I don't think that that's good. I think that that hides important information. I like it in Ruby where your threads are extremely isolated, but in something like JavaScript, I don't think that's appropriate. But what yield does for you is it's a keyword that when you read the function, it's explicit that what you're doing is you're saying someone else can run now. I am explicitly saying someone else can run now, so it has exactly the same semantic meaning as a function callback with less Chrome, right? Less gizmos around it. Okay. What's up?
I mean, if we're just talking about syntax, if we're talking about the visual aspect of writing, triangular message, all that help that everybody's used to, then there's a lot of async function languages that you can actually count.
You're talking about like promises?
No, not like promises, but like async.js or other things that allow you to pass an array of callbacks and actually.
Right. So I think all these things are good. I think all the attempts to, in userland, make the situation better are good. But I think fundamentally, yield is a much more succinct way to say the same thing. It doesn't really reduce any understanding. If you see a yield, it means the same thing as if you saw a callback. And it is possible to do without the big word function. It's possible to do without all the Chrome that comes around a function and return. And what a promise is, it very importantly, lets you have try-catch, which I think is perhaps the most problematic aspect of the userland fixes that exist right now. I just think if you want to say, I want to make an AJAX request, and when it comes back, I want to make another AJAX request with this information, and when it comes back, I want to make another AJAX request. Then I want to animate. When the animation is done, I want to do this. You basically want to describe that as a sequence of things. And if you can describe that succinctly as a sequence of things, I think that reads very well. It's clear. what your intentions are, where almost all the other solutions require experienced JavaScript programmers to understand. And it's a sufficiently common thing that I don't think we need people to be metaprogramming wizards to be able to understand what's going on. Sort of like class. I think a lot of people say, if you're doing anything complicated at classes, sorry, like you should learn prototypes. I think classes are a sufficiently common pattern. People copy and paste that we should just not do that. We should just say, here is syntax that means what you say. Any other questions?
Next question. I give you microphone.
Hi.
Hey.
I'm interested about that promises of values.
Okay.
Yeah. Is there any way how to do it in JavaScript right now instead of that callbacks?
So
you were speaking about that Ember solve this somehow.
So I can talk about what promises are, if that's what you're asking.
Yeah. Okay. And is there another way how to do it instead of that?
So there's no way to get a very succinct, the succinctness of what I showed. But let me tell you what a promise is a object that has a function on it called then, and the then function takes a callback, and that callback gets called when the promise is resolved. So something later will go object.resolve some object, and that will call into the then. And the idea basically is that if you want to say, hey, I have an AJAX call, and when it's done, I want to do this other AJAX call and another AJAX call. Instead of having a whole nested callbacks, you say $.ajax, whatever you want, .then, and then inside of there you do another return $.ajax, and then instead of having a success callback inside, you go .then and then another function that does what's next, right? So it basically flattens it out. Instead of it getting this giant triangle of nested callbacks, it only ever gets one level deep. But in order to do it, you still need a .then, a function, a return value. You need to make sure you're returning promises. Where the yield version, which is only possible with new syntax. By the way, I say new syntax. This feature has existed in Firefox probably for, I don't want to say 10 years, but more than 5. So Firefox, because it implemented a lot of the Chrome of Firefox in JavaScript, added a bunch of features years ago just to make people's lives easier. So yield basically is a way to take the promises pattern, which basically all promises do is it standardizes the idea of there's a thing and it will return a value later, but I don't know what the value is yet. So basically if you write code using that pattern, there's a lot that libraries can do to make that pattern useful. So what Ember does actually is Ember, if you go into, there's an Ember router, and if you go into the router and you want to, let's say you have a /post/1, and you want to show post1, if you return from one of the functions, one of the hooks, if you return a promise, Ember will simply pause, not actually start rendering your page, go into a special loading state, which will let you show a spinner automatically, simply because you returned an object, an Ember data object that was not yet loaded. So basically promises give us a way of talking about the idea that there is a async thing. And what Task.js does, which relies on generators, it says if you use that pattern, if you return me a thing that looks like a promise, I am going to allow you to have this nice syntax if you have ES6.
Okay.
Did I answer your question?
Yeah.
Okay, cool.
Great. Thank you.
Awesome.
Hey.
Hey.
So we're using CoffeeScript.
Cool.
And obviously there's a lot of features in ES6 that are reminiscent of CoffeeScript features that exist today. And I'm wondering whether the working group has given any thought to the migration from CoffeeScript to the new JavaScript version. Is there a notion that it'll replace CoffeeScript, or are they somehow going to coexist?
So I cannot speak for the working group.
What's your opinion?
Otherwise, I would not. There would not need to be a working group. I can say a few things. Number one, every single meeting of TC39 that I've been at, which is now 3 of them since May, something about CoffeeScript has come up as an inspiration for features. So I would not say that all of those features were accepted or even taken particularly seriously in some cases, but people are definitely looking at CoffeeScript to say, okay, people want this feature because of this issue in JavaScript. Here's how we can address it. Example from last meeting is we talked about the soak operator. It just turns out that the semantics are too complicated. It works in CoffeeScript mostly for simple cases, but it's just a weird operator that doesn't do what you would expect in a lot of cases. But we spent maybe an hour talking about it to see if we can make it work, right? So that's number one. Number one is CoffeeScript is definitely, because of the fact that it is not another language, it's basically JavaScript semantics, but with a bunch of fixes. CoffeeScript is a very interesting thing to look at to see what things, it's obviously a list of pain points, things that people feel are painful. So that's number one. Number two, I think ES6 basically addresses maybe all of the things that CoffeeScript is trying to solve, maybe except for everything is an expression, which I think is mostly I think it's a good feature. I like it in Ruby, but I think it's not really a thing that people feel pain from every single day, right? So most of the things that are broken in CoffeeScript are fixed in ES6, or broken in JavaScript that CoffeeScript fixes are fixed in ES6. I don't think people are thinking a lot about a migration path, but there is a lot of interest in making sure that the things that are painful about JavaScript that CoffeeScript is fixing are sufficiently ameliorated so that people who are looking to go from JavaScript to CoffeeScript might instead go from JavaScript to ES6. And I think the transpiler path is definitely the path to victory here. If what you like is like optional white spacing, obviously the 1JS rule stops us from implementing that. Not optional white spacing, a significant white space, or optional parentheses. Things like this are very, very hard to do within 1JS. But I think the really nice thing about CoffeeScript is that it almost itself does not need a migration path, right? It's designed to be quite just another syntax for the same thing. So if you have 100 CoffeeScript files and you decide you want to start moving to JavaScript, ES6, you could simply just move to ES6 and your CoffeeScript files will be relatively interoperable. One last thing on that topic, which is one of the things that I'm most excited about ES6 as it relates to CoffeeScript is that CoffeeScript classes do not do everything they could do because of the fact that you cannot properly implement class-side inheritance in JavaScript, in ES5. So
Because you can't what? Sorry, I didn't hear you.
Class-side inheritance. So basically, if you have class methods, so if you have a class point and you had a create method on that, something like that, right? You had point.create, so methods that were on the actual constructor itself. The best CoffeeScript can do is copy those properties onto the subclass. But if you try to add more stuff onto the parent afterwards, it will not get properly inherited. But ES6 actually has correct class-side inheritance, like every other language. So if you have class methods and then you subclass it and then you modify the parent, it will actually work. So basically ES6 gets to do things that CoffeeScript doesn't because of the fact that sometimes syntax is not good enough, right? Sometimes you need richer semantics.
Cool, thanks.
Cool.
Now we take break, and after the second talk we have some questions and answer with both speakers.
Awesome, thank you very much.
Okay?
Já bych vás ještě na chvíli zastavil. Tenhle talk nebo tenhle meetup byl přece jenom nějak tak jako uspořádaný z Prague.js dohromady s firmou Good Data, ve které pracuju, je nás tady pár, můžete se nás ptát. Kdo máte rádi čokoládu? Kdo potřebujete tušku? Něco napsat, jsou tady letáčky, přečtěte si, co děláme. Určitě se ptejte. Nevím, jestli víte, co Good Data dělá. Good Data je firma, která dělá datovou analytiku pro v podstatě jakýkoliv vstupní data a snažíme se to řešit tak nějak jako na webu. Žije to v cloudu. Jsem trochu nervózní. Snažíme se dělat Web2 aplikaci, která je postavená momentálně nad YUI, migrujeme na Ember. Na backendu máme zajímavé problémy typu distribuovanou analýzu dat. To znamená, existuje hodně věcí, které byste se u nás mohli naučit nebo zjistit aspoň, jak fungují. Takže neváhejte a zkoušejte.